Do some examples of as best I can for the right hand rule for magnetic force on a moving charge. This is where how we determine the direction. Okay, so let's say this is a magnet, and let's say that it is the north side of a magnet. Okay, and if you've watched the previous videos, if you've been keeping track online, we know that the magnetic field for the north side of a magnet goes outward. So the magnetic field would be up here. All right. And let's send a charge through this field in a couple different directions and see if we can determine the direction of the magnetic force acting on that charge. So first of all, let's send a charge. I've already done one to the right in a previous video. Let's say we have a positive charge Q, and let's send it to the left. So it's going to cross that magnetic field right here. What direction is the force acting on that charge when it crosses that magnetic field line? Well, according to the right-hand rule, the force will be, you got it? It's either going to be in or out. Those are the only two options. It has to be perpendicular to both V and B. In this particular case, it's going to be in. The force is into the page, and the symbol for in is a circle with a cross through it. Okay, let me see if I can show you how your hand would be oriented. Okay, so I'm going to draw a little hand down here. So the thumb goes with V, so there's your thumb, and the fingers go with B, so your fingers would point up like this. And if you orient your hand like that, your palm will be facing into the page or into the screen. Okay, let's do another one. Let's keep our magnet like it is. North side of the magnet, magnetic field pointing upward. And let's send the charge in now from, let's send it in from behind the page. Let's have it come out of the board. So V is going to be coming in, the charge is going to be coming in like this. It's a positive charge. So it's going to cross that magnetic field about like that. So when that charge passes that magnetic field line right there, when the charge is there, what direction will the force be? We only have two options. We only ever have two options. It can't be in or out because then it would be parallel to V, and it can't be up or down because it would be parallel to B. It has to be perpendicular to V and B. So the only options are to the right or to the left. And the right-hand rule gives us that it is to the left. Okay, so let me show you how your hand would be oriented for that. You just have to remember which finger and which thumb goes with which. So the velocity is going out. So the thumb, I'm going to draw my hand in green, I think. I'll do orange. Yeah, orange sounds good. So the thumb is pointing that way, and the fingers are pointing up. And if you orient your right hand like that, your palm will be pointing to the left. So the force is to the left. If you did it with your left hand, you get the wrong answer. But if you did it with your right hand, that's what you would get. All right, I'm going to do a few more. Let's switch it up a little bit. Let's say this is a south pole of a magnet. And that's all that's going to do is just flip the direction of the magnetic field. So now it's down. So now we have a magnetic field pointing downward. And let's send a charge in. Let's send a negative charge in. let me move it down a little bit. Let's send it through this magnetic field moving to the right. So let's have a velocity to the right. So when that charge crosses that magnetic field line right about there, remember it's a negative charge, and it's moving to the right with some velocity v, what will the direction of the force be? Well, v is to the right and b is down. So if we use the right-hand rule, let me see if I can draw it again. V is pointing that way, so your thumb will be pointing that way, and your fingers will be pointing downward. And it looks like if I do my right hand like that in that position, my palm is facing into the board. So the force on this negative charge would be in. But since right-hand rule gives us in, and this is a negative charge, we have to flip our answer. So when you're dealing with a negative charge, you've got to flip your final answer. The force is actually going to be out. Since the right-hand rule gave us in, and it's a negative charge, the force will be out. If it had been up, it would be down. If it had given us right, it would be left. So you just flip the direction of the force when you're done if you're doing a negative charge. All right, I think I'll do one more. I think I'm going to flip my magnet, and I'll just do it like that, so be it. Let's say that now this is the north end of a magnet, and now that magnetic field, since it points out of the magnet, it would be pointing to the left. So let's say we have a magnetic field to the left. And I'm actually just going to go ahead and get rid of my magnet because I think y'all get where the magnetic field is coming from. Okay, the magnetic field is coming from a magnet. So the magnetic field is to the left, and let's have a charge coming in. Let's have it going into the page. So it starts here in front of the paper, or in front of the screen, and then it moves and crosses B right here. It crosses that magnetic field right there and goes into the page. So that charge goes in. Let's say this is a positive charge Q going into the page, and the magnetic field is to the left. So the only two options here are up or down. It has to be on a different axis than B or V. B is on the X, V is on the Z axis, so the force has to be on the Y axis. The only question is it up or is it down? And right-hand rule will help us to figure that out. So let me get my little orange hand here. I mean, who has orange hands? I can't think of anyone. But the velocity is to the right, and the fingers are to the left. Sorry, my hand drawing's so bad. So let me just try that again. The thumb is that way, and the fingers point to the left. So if you orient your right hand like that, your palm actually faces up. The palm faces up. So the force on this charge is up. All right. And I think I'll just do one more. Let's have a magnetic field. We've done up and down. We've done left. Let's have a magnetic field coming out of the page. Let's say we have a magnetic field coming out. Remember, the symbol for that is a circle with a dot in it. And let's do a charge. Let's do a positive charge going down with a velocity v. So what direction will the force on that charge be when it gets here? When it crosses that magnetic field line right there, and it's moving downward. Well, we have two options. It has to be either left or right. So let's see. V is down. Let me get my orange hand again. V is down and B is out. So when I do my right hand in that orientation, my palm faces left. If your palm is facing to the right, you're using your left hand. Switch to the right hand. So the force is to the left on this moving charge. Okay, I hope this has been helpful. Put your questions in the discussion board, and we'll see what else we can do to help y'all further. Thanks.